Welcome to a simple explanation of two crucial concepts in machine learning: overfitting versus underfitting. When building a machine learning model, we aim for generalization, but sometimes models run into performance issues that prevent them from predicting new data accurately. Let's start with overfitting, which is often described as too much learning. Overfitting occurs when your model learns excessive detail from the training data, including noise and random fluctuations that don't apply universally. Because the model has essentially memorized the training set, it performs exceptionally well and shows very high accuracy on that data. However, when you test this overfitted model on new, unseen data, it performs poorly because it struggles to generalize beyond the exact data points it memorized. To make this clear, let's use the analogy of a student who is studying for an exam. Imagine a student who only memorizes all the answers from past practice exams instead of truly understanding the underlying concepts. If the questions on the real exam are exactly the same as the memorized practice questions, this student scores very high, success. But if the questions change, even slightly, the student struggles and performs badly because they lack the conceptual understanding needed to solve new problems. Similarly, an overfitted machine learning model memorizes the training data instead of learning the generalized patterns. Now, let's look at the opposite problem, underfitting, which signifies too little learning. Underfitting happens when your model is too simple and fails to capture the essential, important patterns and relationships within the data. The result of underfitting is straightforward. The model performs poorly on both the initial training data and any new data it encounters. Our student analogy also works well for underfitting, representing the truly unprepared student. This student studies very little and fundamentally doesn't understand the topic or the concepts required for the class. Predictably, this student performs badly on practice tests and fares just as poorly on the final exam. An underfitted model is simply too simplistic to capture the complex relationships and patterns present in the data. Let's quickly summarize the core differences between these two pitfalls. Overfitting means the model is too complex and memorizes the data, while underfitting means the model is too simple and misses important patterns. An overfitted model excels on training data but fails on new data. An underfitted model fails on both. To remember this simply, overfitting is too much learning, resulting in memorization. Underfitting is too little learning, resulting in oversimplification.